Yo, Mr. White, what are we learning about today?
I am glad you decided to join us today, Jesse. Today we are going to be learning about the fascinating topic of organic chemistry nomenclature. Does anyone here today know what an organic compound is? How do we define organic compounds?
I think those are compounds that are natural, Mr. White. Like not pesticides and stuff, right, Mr. White?
Not exactly, Jesse. When we think about the grocery store term organic, we think of natural. However, many substances like plastics are technically organic, but are man-made and not found in nature. Organic compounds are simply compounds that contain carbon. They are generally compounds that are associated with living organisms. For example, our bodies contain many different organic compounds. So most organic compounds are synthesized by living organisms. However, many organic compounds are now synthesized in labs and by industry. For example, all plastics are organic compounds, including nylon, styrofoam, PVC, neoprene, mylar, and one of my favorites, Kevlar.
Why would you ever need Kevlar, Mr. White? You're just a high school chemistry teacher.
You never know, Jesse. You never know what the future may bring. There is a slight caveat I should mention. Not all carbon-containing compounds are considered organic. For example, carbon dioxide, carbon monoxide, graphite, hydrogen cyanide, and carbonates, which are minerals, are inorganic compounds. The rule of thumb is basically that inorganic compounds tend to be very simple compounds. There are a few exceptions, but this rule is good enough.
Isn't cyanide poisonous, Mr. White?
Yes, Jesse. There are many compounds that are poisonous. They say that knowledge is power. And I say that someone with an extensive knowledge of chemistry has great power. Power to do many things, both amazing and terrible things.
But chemistry's pretty boring, Mr. White.
It's only boring if you don't understand it, Jesse. Okay, now class. We have, in a previous lecture, talked about common names versus scientific names. If you remember, I said that chemists as a group realized that it would be better if we could all agree on the naming of compounds. The idea was that if I published a paper on a chemical process, I could list the chemicals I used, and everyone would know exactly what I was talking about. The rules we use for naming organic chemical compounds are called IUPAC rules. IUPAC stands for the International Union of Pure and Applied Chemistry. This governing body has a set of clearly defined rules for naming chemical compounds, including organic compounds. One of the most intriguing aspects of carbon is its propensity to bond to other carbon atoms and form long chains. This aspect of carbon is critical to the formation of life on Earth.
Is that what people mean when they say we are carbon-based life, Mr. White?
Yes, Jesse, you are correct. Humans and all other life that we know of base their chemistry on long chains of carbon atoms. These long chains can get very complex.
How are we going to name those, Mr. White? I am still struggling with the name carbon monoxide.
We will start out with simple carbon compounds and keep adding as we go along. However, the chemical names in biochemistry get simplified, so those very complex carbon compounds often have simpler names. So don't worry.
Instead of going over new stuff, can we just have a break today and chill, Mr. White?
No, Jesse, we cannot have a break today. We have a lot of material to cover. We are going to start out with the simplest type of organic compound. These compounds only have carbon and hydrogen in them. That's it. They are collectively called alkanes. They are also known as saturated alkanes because they contain as many hydrogen atoms as possible for the given structure. We'll distinguish these with unsaturated hydrocarbons in the next class. By the way, molecules, whether saturated or unsaturated, are collectively called hydrocarbons if the compound contains only hydrogen and carbon atoms. Carbon atoms, like I mentioned already, have the propensity to bond to one another and can link to form chains, rings, and other complex branching structures. It can get complicated, but we will start with the simplest structure, the straight chain. The simplest alkane is methane. Methane looks like this. It has only one carbon atom surrounded by 4 hydrogen atoms. I want to mention that the electronegativity of carbon at 2.55 is similar to that of hydrogen at 2.20. This makes the bonds between hydrogen and carbon basically non-polar. The results of this is that alkanes are non-polar molecules. You may not care about polar versus non-polar right now, but you will when you get to biochemistry. It's a huge deal in biochemistry.
Doesn't methane come out of a cow's butt?
No, Jesse, you have it wrong. Methane primarily comes from a cow's mouth. The fermentation process in ruminants, called enteric formation, primarily produces methane that escapes when a cow burps.
Cow burps aren't as funny, Mr. White.
Getting back to the lesson. Methane is the simplest organic compound I can think of. Using our inorganic covalent nomenclature rules, we could call it carbon tetrahydride, but methane is easier. Wouldn't you agree, Jesse? Slightly more complicated than methane is ethane. Ethane looks like this. This time we actually observe the carbons bonding to each other, and all other bond positions are saturated with hydrogen atoms. With both methane and ethane, we have fully saturated hydrocarbons, which we call alkanes. If you add one more carbon to the chain, you get propane. We all know propane from our barbecue grills, right? Outdoor grills with their white gas cylinders contain mostly greater than 90% propane. Propane looks like this. We can see that the chaining together of carbons continues. All possible remaining bond positions are filled up with hydrogen atoms. Some of the names we are seeing are going to repeat. So let's take a step back away from alkanes and look at the general naming structure for all sorts of organic compounds. It will take a bit of memorization at first, but it is worth it. Actually, once you get past the first four non-standard names, we start to see the very names we already know.
More things we have to memorize, Mr. White?
If you want to pass my class this semester, Jesse, yes, more things you will need to memorize. We have already seen our first prefix, meth.
Meth, Mr. White? Are you allowed to talk about meth in a high school classroom?
Meth is just a prefix. I am perfectly allowed to talk about the prefix meth in a chemistry classroom.
I don't know about that, Mr. White.
We used meth as the prefix in methane. The prefix meth signifies that there is a single carbon atom. Next is the prefix eth, which we used in ethane. The prefix eth signifies that there are two carbon atoms.
Does propane have something to do with 3, Mr. White?
Yes, Jesse. The prop prefix signifies that there are 3 carbon atoms. Now, so far, you are probably not that familiar with the terms we have been discussing. We have one more unusual name, bute. Bute signifies that there are 4 carbons bonded or chained together. After we get past bute, we get to the names we already know. Pent is next and stands for 5. Think of the word pentagon to help you remember. Next is hex, which stands for 6. Hept is after hex and stands for 7. Oct stands for 8. Think of an octopus when trying to remember this prefix. Then non and dec. You can think of the word decade to help you remember dec stands for 10. There are 2 more which you may want to memorize for the nomenclature exam, but you will probably forget and have to look up later. They are undec for 11 and dodec for 12.
That's a lot to memorize, Mr. White. Do I have to memorize all of these?
Yes, Jesse, for our upcoming exam. Yes, you will need to know them. The prefixes are then applied to the various types of hydrocarbons, like we saw already. We paired meth with ane and got methane. We next paired eth with ane and got ethane. Moving up the list, we get propane, butane, pentane, and heptane. Most of us are familiar with the name octane because it is used in gasoline ratings. Alkanes of different lengths are the primary constituent of commercial gasoline. However, octane is not the primary constituent of gasoline. It is used as a reference to test the gasoline blend. The nice thing about memorizing the prefixes is that they are the same prefixes used across organic chemistry. So we can apply them when we name branched compounds, ring compounds, substituted compounds, and unsaturated hydrocarbons.
That sounds like a lot of stuff, Mr. White.
Well, Jesse, any organic chemist worth their sodium chloride would know all of these terms.
That's a terrible joke, Mr. White. It's not even in good taste.
Jesse, did you just make a chemistry pun? Perhaps you are learning something in my class after all. Okay, we need to learn more about branched chains since carbon often forms branched chains. As I mentioned earlier in the lesson, Carbon forms both straight and branched chains. If the chain is straight with no branches, the naming is very simple. However, if the chain is branched, it gets a little more complicated. When carbon chains are branched, we name the longest continuous carbon chain according to the naming method we just learned. Sometimes this can be difficult if the structure is drawn poorly or in a way that makes the longest chain non-obvious. We next identify any additional chains, which are called side chains, and are named using our same prefixes with a YL ending rather than a ane ending like we used for the unbranched chains. I will start out with some examples and then I will have you try, Jesse. Here, the longest chain possible is fairly obvious. The longest chain possible is 4 carbons long, which we call butane. This is the parent chain. The compound is named using the longest chain, the parent chain, plus the name of any side chains. Now, this particular chain has 2 possible 4 carbon paths. You could start here on the side, or you could start here at the bottom. In either case, the longest chain you can find is 4 carbons long. And actually, for this compound, it does not matter which direction you use. You will end up with the same official name, regardless of the path. I will pick the left carbon as the starting point and designate the lower chain as a side group. This side group has 1 carbon, so we use our prefix meth with the YL designation to get methyl. Now, I have another thing I need to teach you.
We have to learn more, Mr. White? I thought we were done.
No, we are not done yet, Jesse. You have much more you need to learn in this class. Okay, now we also need to number the carbons on the main chain. That is the longest chain. Remember, the longest chain we find is called the parent chain. Chains coming off of the parent chain are called substituents or often just simply side chains. So we need to have some way to designate where the side chains are located on the parent chain. We do this by numbering the parent chain. We have rules for this so that the number system is unambiguous. When numbering, we always start numbering so that the side chains are numbered with the lowest numbers possible. In this case, we will choose to start here on the left side. This will give us the side chain, a methyl group, a number of 2. If we start numbering from the other side, the right side, it would give the methyl group a number of 3, which is higher. So in this case, we must start numbering from the left side. Now that we have the basics of naming and numbering, let us fully name this compound. When we write out the name, we start out with the number of the carbon atom that the side chain is attached to. That would be 2, then we say the name of the side chain, methyl, then the name of the parent chain. Therefore, we call this 2-methylbutane. Notice that there are hyphens between the terms. Let's try another one. This is more challenging since it has 2 side chains. Let us identify the longest chain possible. We can see fairly quickly that the longest chain we can find is 5 carbons long. Interestingly, there are 3 different paths we can traverse to get a 5-carbon parent chain. We will need to see if there is a best path and then follow it. The naming system is uniform so that if there is no best path, then the names will be identical. If there is a best path, we will need to pick the best path. We also need to number the carbons too, so let's keep that in mind as well. The best path is the route that creates the simplest side chains. So therefore, the best path traverses the carbons at the top of the molecule. This will give us 2 unbranched side chains. One is a methyl group, and the other is an ethyl group. We call it ethyl since it has 2 carbons, which is eth plus the suffix YL. If instead we go this way, you get a branched side chain, which is less desirable.
This is too confusing, Mr. White.
Yes, it will take some time getting used to, but with practice you will get it. Well, most of you with practice will get it. Okay, now that we have the best path, we have to number the carbons on the parent chain. Remember, we always number so that the side chains have the lowest numbers possible. We have 2 path choices. If we start here on the left, the methyl group is on carbon 2, and the ethyl group is on carbon 3. If we start here on the right, the ethyl group would be on the 3, and methyl group on the 4. Clearly, the correct choice would be to start numbering on the left side. We now have 2 side chains, 2-methyl and 3-ethyl, plus our parent chain, pentane. When we have more than one type of chain, I have to introduce a new rule. This rule says that we alphabetically order the side chains. So, the correct way to name this compound is 3. Ethyl. 2. Methylpentane. If you follow the rules, it is pretty easy with some practice.
I don't think this is easy, Mr. White. I think I should have taken conceptual physics instead, Mr. White.
Jesse, I am going to have you try the next one. We will take it step by step.
I don't know about this, Mr. White.
You can do it. After all, Jesse, I am an excellent teacher. Let's look at this molecule. First, Jesse, I want you to find the longest chain.
I think the longest chain is 6, Mr. White. Does it matter what path I take?
You are correct, Jesse. The longest chain is 6, and no, it does not matter which path you take. You will still get a count of 6, no matter which path you take. Now, what's a 6-carbon saturated chain called, Jesse?
Hex. Something.
Close, Jesse. Hexane. Okay, now where is the side chain located and what is it called?
It's meth, Mr. White, and it's on carbon 5.
We call those groups methyl groups, and it is on the second carbon. Have you been paying attention, Jesse? We choose to start numbering in a way that makes the side chain the lowest possible number. For this chain, we start numbering here on the right side. So this is 2-methylhexane.
Are we done yet, Mr. White?
No, Jesse, we are not done yet. Please pay attention.
I'll try, Mr. White.
Okay, now we are going to see what happens when we have multiple side chains of the same type. When that happens, we don't want to write out that group name more than once, but we will put in the numbers where that group type is attached. Let's look at this molecule. Jesse, why don't you start out?
Okay, Mr. White, that's butane. The longest chain is 4 carbons, so that is butane.
That's great, Jesse. Now this molecule has 2 side chains that are identical. What are these side chains called? They only have 1 carbon atom.
Meth, Mr. White, meth.
Methyl. Jesse, we call that group a methyl group. So this is 2,2-dimethylbutane. Remember, we start numbering the parent chain so that the side groups are the lowest possible numbers. Therefore, we start numbering from the left side, so we get 2 instead of 3. And since both methyl groups are on the second carbon, we don't have to repeat the methyl twice. We use the prefix di.
This is very confusing, Mr. White.
We use the same prefixes that we learned when we were naming covalent compounds. The prefixes are di for 2, tri for 3, tetra for 4, and penta for 5. You usually won't encounter more than these prefixes in my class, but there are names for higher numbers.
Is mono used for 1, Mr. White?
Well, technically, yes. Mono is used for 1. Generally, however, we don't use any prefix if that is the case. Okay, Jesse, now you try naming the next one.
Is it 2,2,3-trimethbutane?
It's not meth, Jesse. It's methyl. So this molecule is named 2,2,3-trimethylbutane. Okay, Jesse, try this one.
2,2-dimethyl-3-ethylbutane, Mr. White?
This one is a bit tricky because the longest chain is not obvious. The longest chain would follow this path. When you follow this path, you get 5 carbons, so the parent chain is pentane, not butane. So, if you follow the proper path, you have 3 methyl side chains. That makes this molecule 2,2,3-trimethylpentane.
I don't think that I will ever get this, Mr. White. Is it time for lunch yet?
No, it's not time for lunch yet. Please pay attention, Jesse. Let's try a few more. Remember, Jesse, the longest chain may not be the obvious choice.
I could probably concentrate more if I wasn't hungry, Mr. White.
Here's a new alkane.
Well, the longest chain is not the one straight across. Right, Mr. White?
Correct, Jesse.
The longest chain starts at the top left. So we get 6 carbons, which makes it hexane.
Correct again, Jesse.
If hexane is the longest chain, then we have 3 meth groups. Methyl groups. If I number them starting at the lowest, it would be 2, 3, and 4. So the full name is 2,3,4-trimethylhexane.
Excellent work, Jesse. Sometimes when we look at molecules, we see that there are more than one possible longest paths available to us. If this is the case, we want to choose the path that will give us the simplest side chains. With this molecule, we can take 2 paths that would give us 7 carbon parent chains. So the parent is heptane. But which path do we choose? We choose this path. This path gives us 3 methyl side chains and a propyl side chain. If we pick this other path, we would get 1 methyl group and a complex branched side chain. This branched side chain does have a name. It's called a sec isopentyl, for those who are interested. Sometimes in chemistry, you will be required to use these more complicated names. But for this class, I just want you to know it exists.
I think my head is going to explode, Mr. White.
That only happens in movies, Jesse, and to bad guys. People's heads don't normally explode. What you are experiencing is an increase in dendritic connections in your cerebral cortex. In other words, you are learning stuff, Jesse. Here is a very challenging molecule, but it has only simple side chains.
This is terrifying, Mr. White. I think I am going to lunch now.
Let's do it together. With this molecule, I might consider starting at the lower right corner. If I start here, I can trace a path back up to the main chain. Then I will continue up to the top left. Sometimes it's a good idea to trace out multiple paths with a pencil if you are working on paper or with your finger. Trying out a few different paths is generally a good idea. The longest chain, the parent chain, is here and it's 10 carbons long. Jesse, what do we call a 10-carbon alkane?
Decane, Mr. White?
Correct. Okay, Jesse. Start identifying the side chains. Again, if you are doing this on paper, you may want to circle the parent chain like this to help you better identify the side chains.
There are some methyl groups here. Oh, there is another methyl group over here, and there are 2 ethyl groups. What are these called with 3 carbons, Mr. White?
They are propyl groups.
Okay, then it has 2 propyl groups as well.
Correct, Jesse. Now we have the task of deciding which end of the parent chain to start numbering from. First, we should notice that from either direction, the side chains begin at carbon 4, so that is not definitive. We must therefore use an additional rule. Let's try numbering both ways and see what we get. What do we get if we number from the left side? I will put in the numbers if we start on the left.
I guess we get 2 methyl groups on 4 and 1 methyl group on 7, right, Mr. White?
Yes, Jesse, keep going.
Okay. Then guess we have 2 ethyl groups, 1 each on carbons 5 and 7.
What about propyl groups?
Oh, yes, those are the ones with 3 carbons. Right, Mr. White? Those would be on 5 and 6.
Okay, now let's add up those numbers.
4 plus 4 plus 7, then 5 plus 7, and then 5 plus 6. That gives us 38. Right, Mr. White?
Correct, Jesse. Now let's try numbering from the other direction. I will put in the numbers if we start at the other end. What do we have now?
Methyl groups on 4, 7, and 7 again. Ethyl groups on 4 and 6. And the 3 carbon types on 5 and 6.
Yes, Jesse. Those are the propyl groups.
Right, Mr. White. Propyl groups on 5 and 6.
Now what does that add up to? If you add the position numbers?
That makes, let's see, 39. Mr. White.
So, pick the lowered number order. We pick the order that gives us the total of 38. Okay, now Jesse, what is the correct name for this compound?
That would be 4,4,7 trimethyl 5, 7 diethyl 5, 6 di.
Propyl, Jesse. Propyl.
Yes, right. 5, 6 propyl decane.
That's right. You are learning something, Jesse. I told you, Jesse, I am an excellent teacher.
Are we done now?
Not quite.
It's got to be lunchtime by now, Mr. White.
I am almost done, and then I will dismiss the class. I want to spend a few minutes covering the more complicated, branched alkane side chains. We saw one already in this lesson. I don't expect you to know the one we looked at earlier, but I will expect you to know the following side chains. We will first look at the possible arrangements for 3-carbon side chains. There are only 2 possible arrangements. The first is the straight propyl side chain. More specifically, we call it an N-propyl chain, but we usually just leave off the N. However, a 3-carbon side chain can also be branched. Here is the branched 3-carbon chain. We call it isopropyl. There are no other possible arrangements for 3-carbon side chains. Now let's finish by looking at the possible arrangements for 4-carbon side chains. There are 4 possible arrangements for 4-carbon chains. The straight unbranched version is called N-butyl. Again, we usually just leave off the N and call it butyl. A 4-carbon chain can also be arranged like this. This is called sec-butyl, since there is a secondary side chain attached to the first carbon. We can also have this. It is called isobutyl. When you see the prefix iso, think evenly branched, like the letter Y. The side chain is attached to the parent chain by the first carbon, but it is branched, hence the iso prefix. The last possible arrangement looks like this. It is called tert-butyl, since there are 3 side chains attached to the first carbon. The tert-butyl arrangement is the most branched that a 4-carbon chain can possibly be, if that helps any.
My head is definitely hurting now, Mr. White. Is it time for lunch?
Yes, Jesse. It is time for lunch, but tomorrow I will continue on to discuss alkenes, alkynes, and possibly substituted hydrocarbons if we have time.
I can't wait to hear the next lecture, Mr. White. Yo, Mr. White.
What do you need, Jesse? I told you yesterday that we're still having the unit exam tomorrow. An update to Fortnite does not count as an emergency.
Now, Mr. White, it's not about the exam.
Oh. What's your question then, Jesse? Please make it quick. I have a lab to prepare for this afternoon.
Mr. White, you need to subscribe to the GBT Academy YouTube channel.
Why would I need to do that, Jesse?
It's really important, Mr. White. Just say you'll subscribe to the YouTube channel that me and my friends made. It's called GBT Academy. Kind of like ChatGPT, but with a B instead of a P.
Jesse, I don't have time to watch videos of other people sitting around watching people playing video games.
Well, Mr. White, I'm uploading all your chemistry lessons on it.
Jesse?
Gotta go, Mr. White.